Okay, now for this, I'm just gonna talk about what I have already written. So the first thing I did, we want to do this integral. So I asked this question here also, what is the integral if you switch the order of integration? Well, you know, part of this is because when I do these, I don't edit things very well. And you'll see what I mean in a moment. Um, okay, so the first thing that I did was I just drew what the region was. Okay, so x goes from 3y to 9. So I just drew the graph of x is equal to 3y. Then I looked at the graph x is equal to 9. So it's going to be this line and this line. And then y went from 0 to 3. So that gave me these bounds here. This is very similar to what we've done. And then the blue integral is exactly what I did here. I mean, the blue integral is exactly the integral in the form that we were given. Okay, now to switch orders of integration, well, instead of having the x integral on the inside, that means we have the y integral on the inside. And for every fixed value of x, y is going to go from 0 to this line. Well, if I just solve this line for y in terms of x, it says x cubed, or x over 3. So in the inner integral, y is going to go from 0 to x over 3, and then x is going to go from this point to this point, which is 0 to 9. Okay, and then the same integrand. Now, notice that in this blue integral, this is the integral that I gave you. Now, it sort of seems like, from the way this problem is phrased, it kind of seems like you can actually compute this integral, and then this other part is saying, well, now compute it in another way. Well, really, kind of the point of this problem should be the following. The point should be that this integral you cannot compute. So the way that the integral is given to you, you cannot compute it. Why is that? Well, because to do the x integral first is going to require that you find an antiderivative of e to the x squared. And you can't do that, at least not in the way that we want to be able to do it, not in terms of elementary functions. Okay, now down here, if you switch the order of integration, notice what happens. If you do the y integral first, the x integral that you will the x integral that you're going to end up doing is x times e to the power of x squared. And you can do that with u substitution. So for this problem, you actually had to switch the order of integration in order to be able to do the problem. Okay, the integrals we saw above, one way was more convenient than the other way, but in this integral, you actually have to switch the order of integration to be able to compute it. Okay, and something similar is true of problem number 12. So again, this is just a sketch of the region. Y goes from the square root of x to 3, x goes from 0 to 9. Okay, sketching the region from the bounds is something that you need to know how to do. So I start by just graphing y is equal to the square root of x, y is equal to 3, and then seeing what the x bounds are, and this tells me what the region looks like. So the blue integral, again, this is exactly the integral that was given. But notice in the blue integral, again, if you want to do the y integral first, you're going to have to find an antiderivative of 1 over y cubed plus 1. And that's going to be tricky. Now, for the green integral, and then once you do that, if you can do that, that's going to be some complicated expression involving x, because that's one of the limits. And then you're going to have to find the antiderivative of that function. So this is just not an integral that you want to do. But notice that in the green integral, if you do the x integral first, what you're going to end up with is 2y squared over y cubed plus 1. And again, you can do that by using u substitution. In particular, saying u is equal to y cubed plus 1. Okay, so really this question is kind of misleading because I didn't really edit it that carefully for a practice test. So again, the reason I say that is because it makes it sound like it is possible to do this integral without switching the order of integration. And I want you to do that and then switch the order of integration. Okay, well, so what I mean is that, well, really what I should have said here is compute this. Hint, you might have to switch the order of integration.